Hi everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is number of dice rolls with target sum, and it is a medium level problem. So the problem says we have been given n dices and each dice has k faces numbered from 1 to k. Now whenever we roll one of the dices, one of the values from 1 to k will appear and we have to add that particular value into our sum, right? So in total we will roll n dices each with values from 1 to k, and we have to find the number of ways such that the total sum at the end becomes equal to target. Now since the number may be large, we have to modulate this particular value, that is 9 plus 7. So how can we actually solve this problem? So we are going to solve this problem using DP. Let us first understand what are going to be my DP states. So let's say I have DP of ij. What is this DP of ij going to represent? So I is denoting my current index, current starting index, and j is going to denote my current sum, So ij together are going to denote number of ways if I start from the current index with the from the current index I with the sum equals j. That means if I am at the ith index, if I start from this particular position, I am at the ith index and my current sum equals to j, then what are the number of ways to make the total sum equals to target at the end? So what is this index? So let's say I roll my first dice, then second dice, then third dice, then fourth dice, and fifth dice. So each of these places is an index. If I am starting from the second die, let's assume I have already rolled the first die. If I am starting from the second dice, now if I have the starting sum equals to j, what are the number of ways to make the final sum equals to target, right? So what will be our base case in this particular scenario? Whenever I is equals to n and my j is equals to target, that means I have achieved my condition, and my condition was that I have rolled all the dices. That is why I has become equals to n. If I am using zero based indexing, then obviously when I have exhausted all the dice, my index will be n and my j becomes equals to target, right? So these are the two conditions when I is equals to n and j is equals to target. That means I have found one possible way, and that means dp of n target should be equals to 1, because at this particular point of time I have found one valid configuration. Similarly, if I have not rolled any dice, that is 0, I am at index 0 and my current sum is also 0, this would be my starting state and this DP state will store my final answer. Now that we have understood what will our DP state will be storing, what will be our base case or the final condition, and what will be our starting state, now let us figure out how can we actually solve this problem. So I am just going to write a recursive function first of all to help you understand this particular situation better. So let's say I have my helper function and I have initialized two variables I and j, right? Now inside this, let's say if dp of ij is not equals to -1, that is when I am going to return dp of ij. So this is my base condition. Now let me just form one more base condition as well. If I is equals to n, then I am going to return j is equals to target, right? So what will happen when I have reached the last position? That means I is equals to n, that means I have exhausted all the dices. At this particular point of time, if j is equals to target, I have to return 1 or true, otherwise I have to return 0, right? So why is this like this? Because if I have exhausted all the dice and j is equals to target, only then my conditions are satisfied and this is a valid configuration, otherwise I will return 0, right? Now if dp of ij is not equals to -1, I am going to return dp of ij. That means if I have already calculated this particular state, then I have to return dp of ij. Now let's say my current, let me just write dp of ij is equals to 0. Now at this particular situation, there can be multiple possibilities of what the current dice rolls. So it can roll 1 and it can be up to k plus 1, right? Z is less than k plus 1. That means it can be any value from 1 to k, right? Now what I will do, I will set my dp of ij is equals to current dp of ij plus helper of I plus 1 comma j plus z, which is the sum, right? Now I will also have to take the mod, so I do this, and after this loop has been completed, I can just return dp of ij. So you see what is happening here. I initialized my dp of ij with 0, and what I did was, there can be multiple possibilities, so I just made a for loop for all those possibilities, and dp of ij will be equal to dp of ij plus helper of I plus 1. So I plus 1 will be the next index, and my sum has increased by z, that is why I am adding j plus z, right, and then take the mod, and after all, considering all of the conditions, I am just going to return dp of ij. So this would be my recursive solution for this particular problem. Now I will try to convert the same solution into an iterative one, and let us see what will be the solution or what it looks like. So let me make it a little smaller so that you can see both of them together. Now you will realize there is actually very little difference in these two scenarios. So you see, if I show you the main part, so this is the main part, and it is exactly the same. I have made a for loop for z, and I have said dp of ij as dp of ij plus dp of I plus 1 j plus z, right. So this is exactly what I have done here. Instead of writing dp, I have just called the helper function, right. Now talking about these two for loops, this is the only part that is different in both of the cases. So how do I actually determine what are these for loops? The very first thing is, my state of I is depending on a state I plus 1. So what I do, I make a reverse for loop for I, because the state I plus 1 should be computed before state I, right. That is why I have a simple reverse for loop for this particular situation. Now what about the for loop for j? How did I determine this upper limit for j? So j you see is less than k into I plus 1. Let's say I am at the first dice. So if I am using 0 based indexing, I am at this particular dice. So if I am at the index I and I take this particular value k into I plus 1, what does it represent? Let the value of k is equals to 6, right. So k into I plus 1 is equals to 7 in this particular case. So that means my j should be less than 7. What did j represent? J represented the total sum. Now if I am at index I in 0 based indexing, it represents that there were I items before it, right. So for this index there were 0 items before it, there were 1 item before it, there were 2 items before it. This is what I represents in 0 based indexing. So I am using k into I because this could be the maximum possible sum. How can it be the maximum possible sum? Because if there are, let's say, 3 items before the current item, then each of the dice could have a sum equals to k, right. Let's say each of the dice rolled k, right. So if I add 3 of them, so this would be 3k. So that is why I am using k into I, because this is the maximum possible sum that could be encountered for this particular state, right. And I am doing plus 1 because I am using a less than sign here, right. Similarly, while initializing my DP array, I have taken n plus 1 and k into n plus 1. Why k into n plus 1? Because for n dices, the maximum sum can be k into n, and to include the k into n value also, I have to do k into n plus 1, right. Otherwise, the values will only be up to k into n minus 1 in 0 based indexing, right. So if target is greater than k into n, this is my base condition, I directly return 0 because this will never be possible, because the maximum sum is k into n itself, because in n dices I can roll k all the times. Now dp of n target is 1, this is the base case that I have discussed, and I initialize my mod. I have explained you the for loops, why does it work like this, and I have explained you this part as well, where I am going through all the possible situations for the current dice. At the end I can just return dp of 0 0 because I am at the starting position and my current sum will be equals to a in the initial state. So this would be the whole solution of this problem. Now let me just quickly submit this and show you that this particular solution works. I got this runtime error during my first attempt because I did not include this base condition, and this is also very important because we cannot form a sum target which is greater than k into n, right. So this would be all for this particular problem. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and you'll be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.